We have one more exception, and this is valence shell expansion. And this can be the hardest to look out for. Students tend to forget to look for this one, but it's very important as well because there are a lot of structures that are affected by this. And this is only applicable if we're talking about a central atom that has an n value, or principal quantum number, that's equal to or greater than 3. What happens when we have n that's equal to or greater to 3 is that now, in addition to s orbitals and p orbitals, what else do we have available to us? D orbitals, great. So what we see is we have some empty d orbitals, which means that we can have more than 8 electrons that fit around that central atom. If you're looking to see if this is going to happen, do you think this would happen with a large or a small central atom? So think of it in terms of just fitting. We've got to fit more than 8 electrons around here. Yeah, so it's going to be, we need to have a large central atom in order for this to take place. Literally, we just need to fit everything around is probably the easiest way to think about it. And what happens is it also tends to have small atoms that it's bonded to. Again, just think of it in terms of all fitting in there. So let's take an example of PCl5. The first example is the more straightforward example because let's start to draw the Lewis structure. And what we see is that the phosphorus has 5 chlorines around it. So we already know if we want to form 5 bonds, we've broken our octet rule. But let's go through and figure this out and see how that happens. What we know is we need 40 valence electrons, or we have those, 5 from the phosphorus, and we have 7 from each of the chlorine atoms. If we were to fill up all of those octets, that would be 48 electrons. So what we end up with when we do our Lewis structure calculation is that we only have 8 bonding electrons available to us. So we can fill those in between the phosphorus and the chlorine, those 8 bonding electrons. So this is obviously a problem. To make 5 PCl bonds, we need 10 shared electrons. And we know that that's the situation because it's called PCl5 and not PCl4. So we can go right ahead and add in that extra electron pair. So we've used up 10 for bonding. So that means what we have left is 30 lone pair electrons. And I would not recommend filling all of these in your notes right now. You can go back and do that, but just know the rest end up filling up the octets for all of the chlorines. So in this first case where you actually need to make more than 4 bonds, you will immediately know you need to use this exception to the Lewis structure octet rule.